Welcome to video 13 of a series of introductory videos for SolidCAM. This video's topic is the HSR Toolpath. HSR is a 3D target-based toolpath, usually used for 3D toolpaths on very curved, surfacey type parts, such as the one you see on the screen right now. Thermoform parts, a lot of draft angles, a lot of curvature to it. So let's see how we can program with that toolpath. So, as always, I can right-click on the operations folder, add milling operation, HSR, or you could find the toolpath in the ribbon above. Now, to start, let's go with the HM style of roughing. You can see that there are 5 technologies under HSR. HM is the basis one. It's the default one that would have been popped up. And like I said, it's a target-based toolpath, meaning that the target that we selected when we first defined the part is the geometry for this model. It's going to look at the target and machine only that. Let's go to Tool, select my tool. In this case, I'm going to go with my 1/2" end mill. And the only other geometry you choose for the HSR toolpath, other than the target, which is automatically chosen for you, is the constraint boundary. And to get the HSR toolpath to work correctly, you need to provide that. Luckily, it does actually automatically choose one for us, and that is essentially just the outside edge of the part, represented there in green. But if I wanted to focus this toolpath on a particular area, I could use the create manually, and then the various options under create manually to actually create that boundary condition. And once you've created that boundary condition, you can tell SolidCAM how to use that boundary condition. Once again, we've seen this with other target-based toolpaths where I can tell it to machine only what's inside of that boundary area, but allow it to reposition outside the boundary area by selecting external. You can see in the bottom left corner, basically indicates that I'm going to machine what's inside the boundary, but reposition outside. If I switch it to internal, essentially it means that I'm going to machine only what's inside the boundary and only reposition in the boundary. And that's useful for setting up boundary conditions around areas where you do not want to collide with walls or fixtures or anything like that, anything that can be represented by a sketch. The other two options are essentially just staying inside of the boundary up until the center of the tool, or staying inside the boundary up until a tangent point as it leaves. But I'm going to actually switch this to external because there's nothing outside the boundary I need to worry about. So I'm just going to let it reposition outside the boundary. Okay, under passes, passes is similar to the technology section you would see in some of the other toolpaths, where we have control over the particulars of this toolpath. We'll start with the wall and floor offset. Okay, so since we're doing roughing, I'm just going to leave 10 thou on the wall and 10 thou on the floor. The tolerance is, again, being a surfacing toolpath. We're roughing out a surface. We might want to increase or decrease the tolerance of the surface. Essentially, if we were to have been working on a translated surface, you've translated an IGES file or a step file and turned it into a SolidWorks model, that translation probably didn't go too well. You want to just refine or make a much more coarse tolerance on that surface just to get it more machined. And then finally is the step down. And this is essentially the step down as we go across the part. I'm just going to put this in as a 1/4 inch. The Z top, Z bottom, those are our upper level and lower level. And that actually is, in a target-based toolpath, we're just telling it to look at the target in between those levels. So I've chosen the top and the bottom of the stock. It's not going to plunge through the part. It's just going to machine between those two levels from the top to the bottom, and whatever part of the target falls in there is what will get machined. Okay. Point reduction, again, speaks back to the refining of the surface, or refining of the toolpath to make sure that we don't have any kind of weird linear motions. We can probably fit an arc across those linear motions. If I toggle this on and off, you'll see what that does. And again, a tolerance along those points as well. So a surface inside of software like SolidWorks is essentially just a series of points. And by fitting a better point reduction, we could probably smooth out those surfaces better. Now, the actual main part of this window is the step down type and the step over type. Now, the step down type comes in 2 types, constant and flats. Essentially what that'll do is constant will take my step down here and break up the target by levels using that step down. So each level will be separated by that step down distance. If there are any flat areas that fall in between those distances, we can get to them by clicking on constant and flats. meaning that as it steps down in this amount, machining down the part, it'll actually add portions of the toolpath, portions of the G-code to attack those flats. But for the simplicity of this particular one, I'm just going to leave it as constant. Now, in terms of step over, we have step over value. We can toggle this on and put a step over value, or we can put it in as a percentage of the tool. Either way, you toggle one and you choose it. The step over type, however, is a little more important here. We actually have core, cavity, and HM spiral. Core is if we were to machine the part from the outside in. So we would start from the outside of the part and do all our spirals or all our step overs from the outside in. Cavity is the opposite. It actually would start from the inside of a pocket or inside of what essentially is the boundary area and machine its way out. HM spiral is it'll analyze the part a little further to see where they are technically quote-unquote cores and technically where there are quote-unquote cavities. And then it'll either go outside in or inside out, depending on what it analyzes. So we'll leave it at spiral, and we can take a look at that. And smoothing, again, is just another one of those smoothing out of the toolpath. You can see as I toggle it on and off, that image on the left side there shows that it actually will generate a much smoother toolpath. Again, this comes into play when you look at your G-code. Either you have a lot of line segments or you have fit arcs along the code. The remaining tabs here are to further control and further refine the toolpath. So under smoothing, we can either toggle this on and off, and again, we're just going to add a minimal radius or maximum radius on this in this case, so that when we smooth it out, we know to the max radius we're going to smooth it out. Step down, you'll see that it'll actually, once I toggle this on and off, it regulates the actual step down so that it's much more accurate to the surface. And then edit passes. Most people don't use the edit passes, but it gives us the ability to further understand the surface. And again, most people do not even really touch these tabs. These are for the cases where the surface needs that extra little attention. It actually needs to be analyzed a little further so that you can use it for the purpose of your machining. And then finally, under link, we have a few more tabs, again, just to control the toolpath. So you can choose to go climb milling, conventional milling, or you can do essentially a zigzag, doing bidirectional. And you have link options here on how to link those passes. The retract, start, and return points, these are just hints or suggestions as to where the G-code should start. Under ramping, we have the choice of profile ramping, helical ramping, and plunge ramping. I'm just going to go with plunge ramping, so let's make it simple. But you see, once you toggle one of those on, it opens up the parameters for you to control. Strategy, again, just dealing with the surface and what happens with gaps along the surface and whatnot. Retracts, it's essentially controlling the retracts. These are strategies to be applied to the overall target. So they may apply, they may not apply, depending on what your toolpath is like, what your surfaces are like. Okay, so with the HM roughing, let's take a look at that toolpath. Save and calculate. It does the calculation. As you can see, it's analyzing the surface, analyzing the boundary conditions that I put in there. And if we take a look at that toolpath, it's a very, there's a lot of retraction motions. This is a 3D toolpath designed to be used for surfaced parts. If this was a prismatic part, I might end up thinking of using the 3D milling toolpath or the 3D eye machining toolpath. And you'll see those in videos 9 and 10. Okay, so let's open this up, do a save and calculate, and switch it to the next one, contour roughing. Essentially what this is, I'm just going to close this down so that I can suppress the first one. Contour roughing is a different strategy. Again, it's a target-based. And because I did a save and copy, I've saved all the original parameters. So my boundary conditions, my tool, my passes. I'm still leaving 10th out on the wall of the floor. Still going to do a 1/4 inch step down. But because I'm doing contour roughing, essentially what I'm going to do is I'm going to use a contour toolpath over this entire part. You'll see a contour toolpath applied with each step down. Because we've got a contour and there's going to be a lot of arc movements as well, we have a minimum offset and a maximum offset in terms of how we like to attack this part. Here's our smoothing once again. We have additional parameters called detect core areas. So as it analyzes the part, if it sees that there's a core area that it can approach from the outside, if I toggle this on, it'll do so. It'll attack from the outside. It'll approach from the outside and work its way in. Again, the terminology of core versus cavity. Refine corners, as soon as I toggle this on, if you're looking at the left image there, you'll see what it does. It essentially will add a radius on those right turns. We have our Z top, Z bottom just like before, and our point reduction, same as before. And all of these are exactly the same parameters as before. This one is the only one that you'll see a little different. As it goes down in the step down, in this window, it's actually called adaptive step down. It will add those additional passes to make sure that it cleans out any kind of Z levels that it encounters, in this case, a flat. Okay, and the same sort of toolpath parameters under link. If we do a save and calculate on that, again, you see it's analyzing the boundaries. This time it's adding a contour toolpath to this part, and let's take a look at that. So we actually have what looks like more of a contour as it follows along, offset from each edge of the part, and there we go. So once again, let's actually make a save and copy of this, save that copy. I'm just going to go back and suppress this again, because essentially what I'm doing here by suppressing it, right-click suppress, is I'm turning off that toolpath so that it does not post and it does not simulate. And that's important here because these toolpaths work off of the target and the machine stock data. So if I were to have the previous toolpaths engaged, I wouldn't have any material to remove because I'm using a toolpath that looks at that machine stock. So this time we're going to use the hatch roughing. It works exactly the same as we just saw with contour, except this time it's going to put a hatch toolpath. So once again, I'm just going to add refine corners. Everything is the same. If I just do a save and calculate, this time it just does the step over in a hatch pattern, essentially just zigzagging back and forth. And if we take a look at that, you can see that it is zigzagging back and forth, doing contours around the circular areas, but you can see essentially it is just zigzagging back and forth. Okay, so let me suppress that. I'm going to bring back the HM back up. And this time, I'm going to do another save and calculate and show you rest roughing. So the previous toolpath, regardless of which one it is, has removed a large amount of material with a large diameter tool. If I change it to rest roughing and select the smaller tool, in this case, a 1/4 inch tool, constraint boundaries are the same because I did the save and copy. My step down here is going to be 1/8 of an inch because I'm using my 1/4 inch tool. Everything's the same. I'm just going to turn these guys on as well. And once I do the save and calculate, it's going to analyze the updated stock. So it knows that the previous tool removed everything with the 1/2 inch end mill. So what is remaining, it will be only attacked by the 1/4 inch. Once we get back to that, you'll see that the material that was left over in some of these deeper areas, that's what the 1/4 inch was able to do. Okay. So just similar to other 3D toolpaths, really just rest roughing is just a remaining stock, a rest roughing toolpath. If you have any questions on the HSR Toolpath, the various strategies inside of HSR Toolpath, you can give us a call at 1-866-975-1115, extension 2, or you can stay tuned for the rest of the videos where we'll cover other topics. Thank you for watching.